Welcome to this class. In this class, we discuss about how to integrate functions involving products of sines and cosines. So the integrals in this case are of the form sine power mx, cosine power nx dx. Now there are three cases to consider: a case whereby m is odd, or a case whereby n is odd, or a case whereby both m and n are even numbers. So these m and n are integers, majorly positive integers, or there's also a possibility of having a value of m and n being 0. So case 1 is when m is odd, that the power of sine is an odd number. So what you do in this case, you write the integral. So when m is an odd number, then it means that m can be written in the form 2k plus 1. So you write this one as sine of 2k plus 1, and then cosine of x raised to n dx, and then you split this one as sine 2k, and then times sine of x, and then cosine power n x dx, such that this will be the same as integral sine squared x power k, and then sine x cos power n x dx. And you know that cosine squared x plus sine squared x is 1. So where the sine squared, you can write it as sine squared x equals to 1 minus cos squared x. So the integral becomes integral of 1 minus cos squared x, and then power k times sine of x, and then cos power n x dx. And you make the substitution, let u to be cos of x, so which implies du is negative sine x dx, which implies that that the x alone is negative du over sine of x. And so the integral will now be transformed into the new variable u as sine x. So this will be integral of 1 minus u squared power k, and then sine of x times u raised power n, and then dx is minus du over sine x. And so this and this cancels out, so that we'll have integral 1 minus u squared, and then power k u raised power n du, and then there's a negative sign. So this is how we solve problems involving products of sine and cosine when the power of sine is even. So for example, evaluate integral of sine cubed x cos squared x dx. So you see here, m is 3, which is an odd number. So we write this integral of sine power 3 x cos squared x dx. We write it as integral of sine squared x times sine of x and then cos squared x dx. And then this place of sine squared we replace by 1 minus cos squared x and then sine x and then cos squared x dx. And you make the substitution, let u to be cosine of x, so which means that du will be negative sine x dx, which implies that dx alone will be negative du over sine x. So which means that this integral will now be integral 1 minus u squared sine of x, cos squared is u squared, and then dx is minus du over sine of x. And then you cross this and this so that we have integral, factor out negative sign, u so negative 1 minus u squared times u squared du. And so we multiply every term by u squared, so it'll be negative u squared minus u power 4 and then du. So this is negative u power 3 over 3 minus u power 5 over 5, then plus constant of integration c, which is the same as, now when you multiply by negative 1, you'll have u power 5 over 5 minus u power 3 over 3, then plus c. But you remember, u was our own creation, so this would be the same as cos power 5 x over 5 minus cos power 3 x over 5, then plus c. So this will be the integral of sine cubed x cos squared x dx. Now in the next session, we'll discuss the case whereby m is even and odd is the value for n. So case 2 will be, case 2 is when m is even and n is odd. So when this is the case, you rewrite the integral as sine power m x. So remember, n odd means it can be written as 2k plus 1. Then you write cos raised power 2k plus 1 x dx. And then this you write it as integral sine power m x cos 2k x and then cos of x dx, just loss of indices. And then this is the same as the integral sine power m x cosine squared x raised power k and then cos x dx. And you see, we know that cos squared x is the same as 1 minus sine squared x. So you replace at that position. So we'll have sine power m x into 1 minus sine squared x power k and then cos x dx. So you will say we make substitution, let u to be sine of x. So which means du will be cosine of x dx. So this place will be the same as du. Now the integral will be sine power m x. Okay, so sine is the same as u, so this will be u raised power m u power m into 1 minus u squared power k, and then this, all this part is the same as du, as we have seen from this du. So therefore this is the integral that now you differentiate by using concept of power rule. So example, integrate cos power 5x dx. You see this can be written as integral of sine power 0 x cosine power 5 x dx. So our m is 0 and our n is 5. So this odd one is the one that we split into odd and even. So we write cos power 5 x dx as integral cos power 4 x and then times cos x dx. And then remember, cos power 4 can be written as cos squared x squared, and then this you multiply by cos x dx. And you see cos squared is the same as 1 minus sine squared. So this will be 1 minus sine squared x squared cos x dx. And then we make substitution, let u to be sine of x. So which means du will be cosine of x dx. So this position, with this substitution, the position of cos x dx is the same as du, as we have seen from this. So therefore, the integral of cos power 5 x dx will be the integral of 1 minus u squared, because we have said sine is u, and then squared. The place of cos x dx you put du. So you see we have transformed the whole integral just purely in terms of the variable u. So you square this one, you get 1 minus 2 u squared plus u power 4, and then du. By power rule, you'll get u minus 2 over 3 u cubed plus 1 over 5 u power 5, then plus c. So which is the same thing as saying sine x minus 2 over 3 sine cubed x plus 1 over 5 sine power 5 x, and then plus c. So therefore, the integral of cos power 5 x dx is the same as sine x minus 2 over 3 sine cubed x plus 1 over 5 sine power 5 x, then plus c. Now in the next session, we will discuss what happens when both the power of sine and cosine is even. So this is the solution for this. So preserve case 3. For m equals to n, all of them are. So m is even and n is also even. M even, m and n are both even. So that is what we'll do in the next session. Thank you.